Hello everybody. So today me, Ebtisam Qamar and my friend Asma Khalil, we will be presenting our final project in traffic engineering. So first of all, what is traffic engineering? Traffic engineering is a process of using different kind of technologies and certain principles that deals with the phases of planning, designing, and operating any kind of mode of transportation and control traffic. And the main purpose is to ensure the safety of the drivers, pedestrians, and passengers, as it is a science of studying and collecting road data and providing needed appliance and solution regarding traffic. So for our project, we chose Istiqlal Highway. As you can see here, this is the location of our segment and we took it from Google Maps. Now let's see the background of Istiqlal Highway. Istiqlal Highway is a highway that is about 7 kilometers long. It is a linkage highway between King Hamad Highway and Sheikh Salman Highway. Our chosen segment, which is about 1.3 kilometers, that is exactly located between the intersection of Mahzoura Avenue and the Gulf University intersection. Also, the speed limit of 100 kilometers per hour. And since it is a highway that takes you to different locations and linked between highway, it can be very busy and cause traffic jams at peak hour. The purpose of our project is to determine the level of service that we will see at the end of our slides for a specific road, which is Istiqlal Road. In accordance to do that, traffic data collection is needed to be done to collect all needed information, especially during peak hours of the day. These hours could be between 6 a.m. to 7 a.m. and 2 p.m. till 3 p.m. Procedure used for collecting data. First of all, we chose a location that does not have any maintenance. Then we measured the road using the car's meter. A 15-minute trial was done to see how the flow and the volume of the road is. Then we did spot speed study for our road, and to do that we stood at a location that is 400 meters away from the traffic light and used stopwatch from our phone to record the timing. Since speed is equal to distance over time, we used the equation to find the approximate speed of 62 cars. All the measurements including lane, median, and shoulder width were taken using Google Earth. Some calculations were done and we will see them in the coming slides. As you can see here, this is our scaled drawing, and to be able to draw the road, we use drawing application and measurement tools of Microsoft. Also, we had to convert some values in accordance to our chosen scale. Istiqlal Road is a multi-lane highway that has a total of 6 lanes going in both opposite directions. Each side has an approximate of 12 meters in width. Its median, which is a section that separates the lanes from the middle of the opposite direction lanes, has a width of 12 meters too. The shoulder, which is used for an emergency stops or any kind of stop, is about 5 meters in width. Now let's see the calculations. Average speed calculations. After conducting the speed of 62 vehicles, the average speed of 400-meter road length turned out to be 88.5 kilometers per hour. As we know that speed is equal to distance over time, and since we want average speed, so it will be sum of the distance over time over n, which is the number of vehicles. Now let's see in the next slide how we got the value 88.5 kilometers per hour. As you can see in both of the tables, we got the time in seconds for 62 vehicles. After getting the time, we applied the equation, which is distance over time. So our distance is 400, and the first time, as you can see, is 12.06 seconds. So 400 over 12.06 equals to 33.16 meter per second. And after that, we converted meter over second to kilometer per hour. And as you can see at the end of the second table, the average speed is equal to 88.53 km per hour.
Here you can see the frequency distribution table. First, you have to distribute the lower and upper limits, and it is the range of the speed that was found in the speed spot studies. You then divide these speeds into intervals, and as you can see, each interval is divided with a difference of 5 km per hour speed. Then you have to find the middle speed by dividing the speed range of each interval. For example, the middle speed of 55 to 60 km per hour is 5 divided by 2, which is equal to 2.5. Then we deduct the 2.5 from the upper limit speed, which would be equal to 57.5. Then you have to find the number of vehicles. The number of vehicles is that speed is between the range of the upper and lower limit. Then you'll have to find the percentage frequency. The percentage frequency is found by number of vehicles divided by the total number of vehicles, which is 62 cars, then multiply by 100 to find the percentage. Then finding the cumulative frequency is just basically adding the frequency of the table row by row, and it sums up to 100%. Then n times s is just the middle speed multiplied by the number of vehicles. And moving on to the last column is n times s squared, which is the number of vehicles multiplied by the middle speed squared. And here are the graphs, and they are drawn on the basis of the frequency distribution table. The first graph is the frequency versus the speed, specifically the middle speed. And from there, you can find the mode, which is about 88 km per hour. The second graph is the cumulative frequency versus the upper limit speed, and from there you can find the median, which is about 87.5 km per hour. Then, we're moving on to finding the central tendency and dispersion, which are found according to the speed spot values and the graphs shown in the previous slide. The following calculations had been done. Mean is the summation of the number of vehicles times the middle speed divided by the total number of vehicles, which is 62, and the answer is found to be 88.23. The median is found from the cumulative graph, which is 87.5 km per hour, as we said on the previous slide. The mode is the peak of the frequency graph, which is 88 km per hour. Then from the graph, we found the pace to be between 82.5 to 92.5 km per hour. Then we found the standard deviation, which is equal to 13.45. Then we found the percentage pace range, which is found from the cumulative graph. And the speed of 82.5 km per hour is 33%. And the 92.5 km per hour is 65%. Then you find the difference of 65 and 33, which is equal to 32%, and that is the pace range percentage. Then we have to find the confidence interval. The 95th percent is found to be between the range of 84.87 to 91.59. And the 99.7 percentage is equal to 83.1 to 93.36. Chi-square. Chi-square is a calculation of a normal distribution. As you can see from this table, we found the total number of chi-square. First, you distribute the upper and lower limit, and the upper limit must always start with the infinity. And then you distribute the speed in the same way as the frequency table, and then you find the number of vehicles based on the speed range. Then you find the ZD values, which is upper limit value minus the average speed, which is 88.23, divided by the standard deviation value, which is found to be 13.45. Then you can find the probability, which values are found from the probability table. The occurrence of probability is the difference by the first and second value probability, and from there you go one by finding the differences by going down row by row. The theoretical frequency is found by the product of the occurrence of probability and the total number of vehicles, which is 62. In combined group column, any value from the theoretical frequency that is less than 5, its number of vehicles has to be grouped. As you can see, the first three numbers are less than 5. So you add the number of vehicles, which is 1 plus 4 plus 2, and it's equal to 7. And then lastly, you will find through the calculation the total number of chi is 3.169 and the degree of freedom is equal to 5. From the table, the probability, which was done by interpolation and had been found to be 0.6763, which is 67.63%. According to this percentage, which is more than 5%, it is a normal distribution.
Volume is the number of vehicles passing a point during a specific time. In the table below, you will find the counts from 2 to 3, which is the peak hour. We chose to do a 13-minute interval for a whole hour. As you can see,
here we found the total number of vehicles. We combined the passenger cars and the heavy vehicles from the right direction and the left direction. The total number of vehicles for the right direction is 2,835, and the total number of vehicles from the left direction is 2,307. And then we find the number of percentage of passenger cars and heavy vehicles for each direction. In the right direction, we found that the passenger cars has a 93% and the heavy vehicles is 7%. And from the left direction, we found that the passenger cars is 89% and the heavy vehicles is 11%. Then, you have to find the peak hour factor. The peak hour factor is the total volume divided by 4 times V15. V15 is the volume of the 15-minute interval. As you can see here in the table, for example, the right direction has the V15 of 762 and a total volume of 2,835. From there, you take the 2,835, you divided it by 4 times 762, which will give you a peak hour factor of 0.93. Lastly, you have to find the level of service. The level of service is a term identifying the quality of the road based on the available provided services in a particular road. It ranges from level A to level F. A being the best condition where there is comfort for the driver and he or she has the ability to drive in a free flow speed. And F being the worst condition where the driver has no comfort and there will be traffic jams. The level of service for the right direction. Previously, we have found the volume for the right direction to be 2,835, and the free flow speed is equal to 55 miles per hour, and the peak hour factor is 0.93. The number of lanes for the right direction is equal to 3. PR is equal to 0%, and the truck's percentage is equal to 7. ER and ET level terrain are found from the table, which is 1.2 and 1.5. Then we found these values. FHV equals to 0.966, VP is equal to 1051, and we found the speed, which is 55 miles per hour. And from there we can find the density by dividing the VP and speed, which is 1051 divided by 55, and it's equal to 19.12. And going to the density table, it will give you the level of service that is equal to C. Then, the level of service for the left direction. The volume as previously found was 2,307. The free flow speed is 55 miles per hour. The peak hour factor is 1.01. The number of lanes for the left direction is 3. We found the percentage of trucks to be 11, and as previously said, ER and ET level terrain values are from the table, which is equal to 1.2 and 1.5. The FHV value is equal to 0.95 and the VP is 810 and the speed is 55 miles per hour. Again, from there we can find the density by dividing 810 by 55 and it gives you the value of 14.72. And from the density table you'll find the level of service to be B. In conclusion, in this project we learned some major parts of traffic engineering and data collection. We've done some trials and speed data collection on Istiqlal Road, that is a 6-lane highway. We took the road measurements and the length of our segment, which was 1.3 kilometer. Finally, we found out the level of service, which turned out to be C for the right direction and B for the left direction.